Introduction. In vector calculus, there are two theorems that are important, which are Green's theorem and Stokes' theorem. These theorems are named after George Green and George Stokes, and there also involve a third person in this theorem named William Thomson, or known as Lord Kelvin. Green's theorem expresses the relationship between a line integral in a plane around a simple closed curve C and a double integral over the plane region R bounded by C. It's a two-dimensional version of the broader Stokes theorem. Let R be a simply linked plane region whose boundary is a simple, closed, piecewise moved curve C oriented counterclockwise as its border. If FPQ and GPQ are continuous with continuous first partial derivatives on some open set including R, then we can look into the equation 1 given. To keep things simple, we will demonstrate the theorem for both type 1 and type 2. Figure 1 depicts just such a region. We can look into equation 2 and equation 3 given. Stokes' theorem states that the surface integral of the curl of a function across a surface limited by a closed surface is equal to the line integral of the particular vector function around that surface. In this theorem, the curl of a vector phi was defined as below as the equation 1 given. Consider sigma be a piecewise move oriented surface circumscribed by a simple closed piecewise move curve C with positive orientation if the vector phi component as below are continuous and have continuous first partial derivatives on some open set containing sigma, and if T is the tangent vector to C, then we can look into equations 2 given. Stokes' theorem is often used to calculate work around piecewise move curve with several sections since it eliminates the requirement for a separate integral evolution over its sections. We can look the equation 3 below.
Assalamualaikum. I am Hainus Munawara and I will present about the similarities and the relationship between the Green theorem and Stokes theorem. The similarities between Green theorem and Stokes theorem. This both theorem is part of fundamental theorem of vector calculus. Green theorem was implemented in 3 dimensions by Stokes theorem. As both theorems have more in common than the others, they are both the same theorem with a different number of dimensions. The similarities between Green theorem and Stokes theorem are they both deal with closed line integral with a surface integral, but they only differ in how they are applied around a plane of curve. The relationship between the Green theorem and Stokes theorem. The line integral of a two-dimensional and the double integral over the region it encloses are related according to Green theorem, as the theorem has a specific case in which the integral of the conservative field over a closed path is 0. The relationship between these two theorems is the closed line integral and the surface is bounded by closed line integration. Green theorem relates a line integral around a simple closed plane curve C and double integral over the region enclosed by C. These two theorems are related because Stokes theorem is a higher dimensional version of Green theorem. In short, Green theorem is a special case of Stokes theorem in which Stokes theorem for a positive orientation is identical to Green theorem.
My name is Nuriza binti Osman. I would like to present 5 mathematicians and physicists. First, George Green. George Green was a British mathematical physicist. He was the first to propose and discover the theorem which is recognized today as a Green theorem and Stokes theorem. For George Green's academic background, he only attended Robert Goodye's School in Nottingham for 4 semesters for formal education. Then, he quit school and goes to do work at his father's factory. Green joined a library in Nottingham in 1823 and had access to more advanced mathematics. Then, Green was admitted to Cromwell and Caius College, Cambridge, as an undergraduate in 1832. Thomson is also known as Lord Kelvin. William Thomson was an Irish Scottish mathematician, mathematical physicist, and engineer. Kelvin pursued physics and engineering for the rest of his life by making fundamental advances in the theory of heat, electricity, and magnetism. Kelvin is the name of the unit on the absolute temperature scale. He was a prodigy as a child. At the age of 10, he enrolled at Glasgow University, and in 1841 he enrolled in the University of Cambridge. While working at the university, he came upon for the Green's work. He was appointed as a professor at the Cambridge University in 1846. He learned her Bachelor of Art and served as the second wrangler, which is ranked second in the list for those obtaining a first-class degree. Next, Augustin Louis Cauchy. He was a French mathematician, engineer, and physicist who was considered one of the world's best mathematicians. He received his first formal education at a secondary school in Paris. Then in 1805, he took and passed the École Polytechnique entrance exam. Stroke was an Irish English physicist and mathematician. His first formal education was at the Reeve R.H. Wall School in Dublin Home Street. At the age of 16, George Stroke travelled to England and enrolled at the Bristol College in preparation for his study at the Cambridge University. Pembroke College awarded him a fellowship once he graduated. When Stroke served as Master of Pembroke College, he got the highest possible honour from his alma mater. To solve this Stokes theorem, Kelvin collaborated with him. Lastly, Hermann Henkel. Hermann Henkel was a German mathematician. Henkel's formal studies started when he attended the Nikolai Gymnasium. Next, Henkel was enrolled into Leipzig University in 1857. At the university, August Envious taught his mathematics, while his father, a physics professor at the university, taught him the physics.
Hello, my name is Nurhusnina binti Hassan. I will present about roles that Green, Thomson, and Stokes play in discovery theory. It all began in 1823 when Green wrote an essay on the application of mathematical analysis to the theory of electricity and magnetism. It contains what is now known as Green's theorems. In 1845, William Thomson accidentally discovered a photocopy of Green's works, which he reprinted because of Green's importance in mathematics. Thomson continued his study in physics and chemistry, made significant discoveries to heat, electricity, and magnetism theory. Kelvin is the name of the absolute temperature scale unit. In 1854, Stokes began to investigate Green's work by presenting the theorem as a question for the Cambridge examination.
I'm Anis. Next, I will present for investigation of electricity and magnetism. Green's theorem. In 1828, George Green published the first mathematical theory of electricity and magnetism in his essay called An Essay on the Application of Mathematical Analysis to the Theories of Electricity and Magnetism. Green enhanced and extended the electric and magnetic discoveries of Simon Denis Poisson, a French mathematician. This publication also established Green's theorem, which is extensively used in the study of magnetic and electric field potential characteristics. Next, Stokes theorem. Stokes theorem, commonly known as Curl theorem, is the most widely used theorem in the fields of electrical and magnetism. Both the Maxwell-Faraday law and Ampere's law contain it. To move between the differential and integral forms of the equation, Stokes' theorem is utilized in all circumstances. Electromagnetism with their theorem of Faraday's law of induction in Maxwell equation. In a circuit, the electromotive force is equal to the circulation of the electric field around the circuit, such as follows formula. Faraday found that changing magnetic flux EMF equals to negative d empty set dt, where empty sets equals to double integral of b multiplied by Cartesian n ds, induces an electromotive force in a stationary circuit, and S are any capping surfaces of C. Next examples and theorem is butterfly net. Stokes' theorem requires that the two integrals have the same orientation. This is easy to do if the loop is in the xy plane. Choose upward flux and circulation in a circular direction. The circulation for any or less planar loop should be counterclockwise when viewed from above, that is, from the direction in which the flux is taken. As a result, start in the direction of negative flow. Take the flux up and the circulation counterclockwise when viewed from above, with obvious change if the loop is sideways. Last but not least, permanent magnetic speakers. Electromagnetic devices include magnetic speakers, which are often seen in televisions and radios. Electromagnetic ideas are used to operate this equipment. The speakers turn the electrical pulses into audible sound. A magnetic force is applied to a metal coil, which generates a magnetic field when current passes through it.